In these questions, we're just going to practice finding a derivative. So in question A, we have a square root function. We should recognize that the square root function has a horizontal compression factor of 3. The plus 2 in this expression is a horizontal shift, which does not affect our differentiation. So we don't need to account for the plus 2, but we do need to account for the times by 3 horizontal compression. So to make it easier to apply the power rule, I've written this as a power 1/2, and I'm going to now apply the power rule here. So we have f prime of x. I bring the power to the front, 1/2, and then we have 3x plus 2. The exponent, we subtract 1, so we end up with a negative exponent, 1 negative 1/2. Now again, because of that extra 3, we have to account for that with a times by 3. We want to rearrange this so that we have all our parts in the numerator and denominator correctly. That's going to be 3 on top. Okay, so in our fraction solution, we're going to have 3 on top. We're going to have a times 2 on bottom. And that negative power is going to be in the denominator as a square root. So we end up with 3x plus 2 in the denominator, and that represents our derivative function. For B, we're just going to differentiate again, but we want to just account for that extra horizontal compression factor of times 2. So f prime x. The derivative of sine is cosine. The 3 does not affect our derivative, so we're going to end up with cosine 2x. We need to make sure that we account for that extra times 2, the horizontal compression, with the times 2 onto the derivative, and then our plus 1 differentiates to 0 since that's a constant. And again, we want to group our coefficients, so we get 3 times 2 is 6, 6 cosine 2x. For our log function, what we can do is, well, firstly, we need to recognize that if there's no base written, we have to assume that it's base 10. That's the default base when there's no base written. And we should also recognize there's a times 2 in here, which is a horizontal compression that we have to account for. And then we have our constant plus 3, which doesn't affect differentiation. So I'm going to do this 2 ways. We'll just use our formula. So we have f prime of x. When we apply the formula, we're going to have 1 over 2x. We have to account for that extra, the non-base 10, by dividing by the natural log of 10. And because of that extra 2, we're going to multiply times 2. And then we have our derivative of 3, which is plus 0. We don't really need to write that in, but I just want to show you that it exists. And then we can simplify this expression. And notice that that times 2 and divide by 2 will cancel out. Now that coefficient always happens to cancel out. So then when we rearrange this, we end up with 1 over x log base e of 10. So that's one way we can do it. We can also, and this is a strategy that I think is better, is actually just change the base right away. It's much easier doing calculus in base e. So I'm going to take that original expression and you apply the change of base formula. So instead of log base 10 of 2x, I'm going to do log base e of 2x divided by log base e of 10. And then we also have to remember our plus 3. So that's my original function. And I can again differentiate this. The derivative of this becomes the 1 over log 10 is the 1 over log 10 is a constant, so it doesn't involve in our derivative. So I'm just going to put that on the outside. And then we could take that log base e of 2x, and we're going to differentiate that. That becomes 1 over 2x. Remember that horizontal compression? We have to account for that horizontal compression with that extra times 2. And then the derivative of the plus 3 just becomes 0. Again, you don't really need to write that in, but I just want to show that. Make sure that we know that what's happening with that 3. Those 2's cancel out. And then we end up with our derivative being 1 over x log 10. Okay, and notice that the derivatives in both cases still match. Regardless of how we do it, it should end up being the same. Okay, so this one, the next one, D, it just involves differentiating an e function or an exponential function. Since it's base e, that's great. It's just going to be derivatives of exponentials are themselves. If it's base e, we don't have to account for anything, so it just becomes e to the x. We use power rule for x cubed, 3x squared, and then we use power rule for x, so we just end up with minus 1, and there's our derivative. For e, we have to just be able to differentiate the e to the x function and the tan x function. Just make sure that we keep track of that extra horizontal compression of times 5. The 2 doesn't affect our derivative, so our derivative just becomes itself e to the 5x. But because of that extra times 5, make sure we account for that with an extra times 5. Plus, derivative of tan is secant squared. This is just a known derivative. And that's our derivative. We want to, again, group our coefficients. This becomes 5 times 2 is 10, e to the 5x, plus secant squared x.